In this video, we're going to look at an example where we try to find delta given epsilon. All right, so again, recall our formal definition of a limit. The limit as x approaches c of f of x is equal to L. That means that for every epsilon greater than 0, there is a delta greater than 0, such that if 0 is less than the absolute value of x minus c is less than delta, then the absolute value of f of x minus L is less than epsilon. So we start off with a value of epsilon. We're going to try to figure out what value of delta could we choose that would make our statement true. So here in this problem, we have this limit. The limit as x approaches 3 of 4x minus 5 is equal to 7. In this problem, what is our value of c? Well, so the value of c, that is the value that x is approaching, right? So our x value is approaching 3. What is our value of L? So L is the value of the limit itself. So our limit is 7, or we're claiming it's 7. And our function, f of x, is 4x minus 5. So we are going to think about having epsilon be equal to 0.01. We are going to then find a value of delta that corresponds to that. So what we will do is we're going to start here, and then we're going to work backwards and figure out what value of delta would we need to have had in order to hit this restriction. So we have the absolute value of f of x minus L is less than epsilon. In this case, f of x is 4x minus 5. The value of L is 7. The value of epsilon is 0.01. So what we would like to do is we would like to go through a series of steps and end up with the absolute value of x minus c is less than delta. And so in our problem, our value of c is 3. So we need to get to an absolute value of x minus 3. And then we'll have some number over here. That number that we have on the other side is going to be our delta. All right, so now we need to just fill in the gaps between these two things. So let's just start doing some algebra. 4x minus 5 minus 7 is 4x minus 12. It's less than 0.01. We can factor a 4 out of this mess here. And so we will have 4 times the absolute value of x minus 3 is less than 0.01. Oh, and we're trying to get the absolute value of x minus 3 on this left-hand side. So to do that, we can just divide by that 4. So if you divide both sides by 4, then we have this is our value for delta. 0.01 over 4 is 0.0025. So delta is equal to 0.0025. And just like that, we have found a value of delta that ensures, as long as our x value is within 0.0025 units away from 3, then our function value is going to be no more than 0.01 units away from 7. So as long as we're this close to 3, then our output is going to be this close to 7. All right, In the next video, we're going to continue this idea, but we're going to do it arbitrarily. And so instead of having a specific value of epsilon, we're going to leave it as epsilon. We'll write delta in terms of epsilon. And then we're going to actually go through and do a proof. And so we'll look at that next time.